In this lesson, we're going to consider three-dimensional trig problems. Here's a typical example. Herbert and his brother Filbert are trying to storm a castle and want to figure out how high the castle wall is. Unfortunately, there's a moat around the castle, so they can't get close to the walls. In order to figure out how high the walls are, Herbert, shown here in the diagram, sights a 50-degree angle from the ground and the water to the top of the castle. And then Filbert walks 70 meters away, so this is 70 meters, on the same side of the moat. Now, measuring from the line in between Herbert and Filbert to the base of the castle, they get angles of 85 degrees and 75 degrees, as shown here. The question is, with this information, can you figure out how high the castle wall is? So here's the same diagram again. We know that this is 70 meters. And we're going to assume that the line along the ground and the water and the line up the side of the castle wall are perpendicular. So this is a right angle. Now, the first thing to notice is that the diagrams can be a little bit misleading at first because, given that it's shown in perspective, this doesn't look like a right angle shown here. The second thing to notice is that this is going to be a multi-step problem because I don't have enough information at hand right away to solve for this side length, the height of the wall, in one step. So I'm going to need to work backwards to figure out what information I need in order to work up to this. Now, working backwards to set up a plan is a good idea if you can do it. Sometimes you won't be able to see what to do, and just starting to work with some of the numbers and some of the sine law, cosine law, or the primary trigonometric ratios will help you work towards an answer. Now, in this case, though, let's try and talk through what we're going to do. So I want this side length, and I have that this is a right angle, and I have this angle, but I don't yet have enough information to use my primary trigonometric ratios in this right angle triangle because I don't have another side length. If I had either this side length or this side length, I'd be able to use the appropriate trigonometric ratio and this angle to find this side length. Now, finding the hypotenuse anytime soon doesn't seem likely because it's far away from all my given information, but this looks like a side I might be able to find soon. Now, this triangle down here contains a lot of information, so that gives me more hope. This is going to be a non-right angle triangle because I've already got two angles here that sum to more than 90. So I know I'm going to be using either the sine law or the cosine law down here to further my progress. And if I look at the information I'm given, two angles and a side, that's a setup for the sine law. So looking at it this way, it seems that my plan is going to be to use the sine law in this lower non-right angle triangle to find this side, and then to use a primary trigonometric ratio and this angle to find that side. Again, you might not always be able to work backwards through this kind of plan. You might just need to start working with stuff and seeing what happens, but that's what we're going to do here. That's our plan. So that means I'm going to need to find this angle. I'm going to call this angle C for castle. Angle C then is equal to 180 degrees minus 75 degrees plus 85 degrees because all three angles have to sum to 180, and that's going to be equal to 20 degrees. And I'm going to label that on the diagram to help me keep track. Now, I've got an angle and the opposite side, and an angle and a missing opposite side. This is the one that I want. So that's a setup for using the sine law. Now I'm going to name this side as well, and because it's opposite angle, capital F, I'm going to name it lowercase f. By the sine law, I know that f over sine of 75 is equal to 70 over sine of 20 degrees. Rearranging, I get that f is equal to 70 sine 75 over sine of 20. And plugging that into my calculator in degree mode, I get that f is approximately equal to 197.69 meters. And I'm going to leave that number in my calculator so that it can carry forward as many decimals as it holds to ensure greater accuracy later. So now I have this side length here, and I'm one step further to figuring out this side length. I'm going to redraw that top right angle triangle to make things a little clearer. If this is 50 degrees, and this is 197.69 meters, I'm now looking for this side length here. And because it's a right angle triangle, I can use the primary trigonometric ratios, sine, cos, or tan, as appropriate. And I need to ask myself which is the right one to use. Well, I've got this angle and the adjacent side, and the side that I'm looking for over here, let's call it W for wall, That's the opposite side. So I've got opposite and adjacent, therefore the relationship that I'm looking for is the tangent relationship. And I set that up as tan of 50 degrees is equal to W over 197.69. And again, I'm keeping this in my calculator with further decimals for greater accuracy. Rearranging then, I get 197.69 tan 50 degrees is equal to W, and my calculator gives me that W is approximately equal to 235.6 meters, and I'll keep one decimal place for accuracy. So that's how we've worked through this process of figuring out the height of that wall. A few tips then that we can take from this for 3D trig problems. In this case, we were given a diagram, but if we weren't, that's the important first step. It's going to make everything obviously that much easier, and it's really almost impossible to work through the problem if it's at all complicated without doing that. It can be helpful to work backwards to figure out what you need to find. We did that in this case, and to label sides and angles as you go along in order to keep track of them. One thing that some students do is they call everything x, but that can be confusing as you go through because you're looking for multiple different side lengths, multiple different angles, and so if they're all called x, that can be very confusing both to yourself and to the person who's reading your work. Also, if the drawings themselves get confusing, you can try drawing the triangle separately as I did in the example. Sometimes it's helpful to do that right away in order to keep things clear. So that's an example of solving a three-dimensional trigonometric problem.